One, blast off. All right, everyone. Welcome to the final class in the SQL 101. In the SQL 101 class, I'm Jeremy Bergman, professor here at Omaha Data Science Academy, and this is Advanced Database Functions. What we'll learn here today is some of the programmatic features of database, including temporary tables, common table expressions. Both those help simplify queries. We'll also learn about programmatic features in the database. So if you want to create some of your own custom functions or some advanced functions, the MySQL gives you some of the capabilities to do that. Also have stored procedures, which is like a long, allows you to run not just one query, but even multiple queries or code sequentially. And then database triggers, which they are triggered, like they say, they're triggered or they're an action based on another action in a database, then update or delete, insert type operations on table. So we'll see examples of those today. All right. So class 8 objectives covered temporary tables, common table expressions. We'll do that first because you can also use these in procedural SQL. So that's what I talk about when we talk about advanced SQL. We're talking about procedural aspect of MySQL database. So what is the difference between what we've learned, the standard SQL versus procedural SQL? Standard SQL is what we have learned throughout the class. That's a common language used to communicate with the relational database. It's a single piece of code that operates one query at a time. You can, even though you can put multiple queries in a SQL file, it really like runs one and then runs the next one and then runs the next one after that. So it is like SQL. It's a language used to communicate with the relational database to tell it what information or what operation to do on the tables. So procedural SQL is more like a programming language where you can create like a function or like a small application. It's called PL SQL in MySQL. So you can actually use SQL inside of it along with procedural features of programming languages. So you can use SQL code, and we'll see that you can also use some programming type syntax in there to create those little small programs that we talked about. They will look relatively familiar to you. It's still based on SQL, but you get some added functionality to really customize things in the database. I should say procedural SQL. Most major database systems have some type of procedural SQL. So it's PL SQL in MySQL. It's called T-SQL in Microsoft SQL Server. I know Postgres has their version of it too. Usually it's some slightly different flavor in each database. And that's probably where you'll see most of the differences. It's not in the standard SQL quite as much between databases. It'll be in the procedural SQL and how they allow you to build these advanced features or functions or routines within them. So we will cover procedural SQL more in depth. So we'll cover the structure, how you build it, syntax. So some of the things that you have to do, like the syntax of a standard SQL query, there's some things that you have to do with procedural SQL. And then you can use variables in procedural SQL. So you can declare variables that store values temporarily, just like a program, and just like you'll find in a language such as Python. Then once we learn that structure, then we'll learn more about SQL routines. So stored procedures, triggers, and functions. Yeah. Well, for temporary tables and CTEs, so common table expressions. So these are both defined temporary result sets that can be referenced in a query syntax. So I'm going to jump over here and show you the syntax for each one of these and explain what each one is. So a temporary table is just like a table that you would build within the database, within a schema or a database. However, it's a temporary table. So temporary tables exist only for the duration of a session. So we talk about tables in a database being persistent. We use that term early in the class. This is a table that's actually only persistent while you're connected to SQL. So that would be is if you're in SQL and your connection's active, but once you disconnect from your session, that temporary table will go away. And you'd say, well, why is that useful? One reason it'll save space in the database from storing results. You don't always necessarily need to store a temporary table or a table with data in it and have a whole bunch of tables that you aren't going to reference later on. But two, I also use it to simplify. I really use temporary tables to simplify queries. So if I have a multi-step query where I need to put data in one table, store it temporarily, and then use that result in the second table, I do that often. I actually do that more often than I use subqueries. I use subqueries sometimes, like in statements or a simple subquery if I'm doing something like that. But I tend to break them down into either temporary tables and put the results in there and make a more straightforward join with it. Or I can use a common table expression. I do some of that too, but I use temporary tables a lot, which can also be used in when you create either functions or stored procedures, as we'll see shortly. How a CTE is different, so common table expression. These are only built during the duration of the query. And you see it's a little bit different because it's just a result set. You don't have to create the table structure for the table. So it just stores that result set, and you would call it with, you don't have to necessarily call it CTE. You can give it any name that you want, and then define your query on the inside. And then you have these parentheses, and then you could use it in the table below. You can actually do these as a series of queries. You can do with CTE and CTE1 and CTE2, CTE3, and so forth. So temporary tables. So why you'd want to use a temporary table? They're better at separating data and storing results that may be used many times in a session. That's one thing that it's good for, is that it's reusable during a session instead of just one time. One advantage to CTE is that it can simplify subqueries and joins, just like temporary tables, or more complex operation like recursive queries. So you can actually stack common table expressions within each other like a bunch of subqueries and do that recursively. There's an external resource here if you want to learn more. You'll see code like this quite a bit from data analysts if you're trying to take something complex and make it not as complex. Personally, I like temporary tables for that. That's my opinion, but I've definitely used common table expressions before if you just want a simple result, or if you just want a result and be able to join that with a table, or recursively do it with a table. Okay. So wouldn't you use one over the other? Oop, that's actually the same thing we started to talk about. So basically temporary tables for a single session that you use multiple times. CTEs to simplify subqueries or allow more complex operations. These only last during the duration of the query. This one lasts for the permanence of the set. Permanent for the session. Yeah. So those are those. I wanted to cover temporary tables and CTEs first because these can be used within procedural SQL. So we briefly covered this at the beginning. Standard SQL refers to syntax and semantics of the SQL language. It's a common language used to communicate with the databases. That's what we've used throughout this class. These statements are executed one at a time, which means that they're non-procedural. So what the database does, it takes that query, it takes it and compiles it and puts it in its own language to navigate the database to either get the results that you want from a query or do database operations like insert, updates, deletes. It actually interprets what you write and then takes instructions from that and changes it into code that the database can use to execute that statement that you wrote or that query that you wrote. So procedural SQL is a little bit different. It's an extension of standard SQL, enables developers to include programming constructs like procedures, functions, and triggers. They're executed in a scripted fashion. So scripted fashion is key. You'll do some of this, more of this when you're in Python class. You'll do a lot of scripted routines, which is one of the big powers of Python. You know, it's also useful sometimes in procedural SQL, as we'll see. But the code is processed in order with each statement is written from top to bottom. So we'll see here shortly, but you have a syntax, and then you could have multiple steps. You could have query 1, query 2, query 3. You can do an if statement in there, and it has quite a bit of power, use different variables, return different results, and so forth. So there's a lot of additional programming like power that you get out of procedural SQL, and while using being able to use all the features of standard SQL. All right. So procedural SQL, the structure of it is first you declare your procedure. So when you declare your procedure, you'll actually first create a procedure with a name like you would a table, because a procedure, I'll bring it up here in MySQL, because a procedure is really just another database object. Stored procedures and functions are really other database objects that you can create. So you can use the same create syntax or the create keyword. Here's Sequila's actually a really good example to be able to create a stored procedure function. And then inside, once you do that, then these are the steps you take. So you can declare keyword, it'll declare your variables, constants, and even records can be declared, which stores data temporarily. So what this is that you can declare variables in different data or constants or even queries and hold those in a variable or a result set to start. So you're declaring those variables before you start at the beginning of the procedure. The execution of the procedure, it starts with the begin and ends with the end keywords. So these are both mandatory, where declare this can actually be optional because you don't necessarily need any of this. Oftentimes you will declare variables, but not necessarily. You may just have a bunch of statements that you execute, and all you need is a beginning and an end. So one of the keys, it supports all DML, DLL commands, and SQL built-in functions. So anything that we've learned in class, you can put in this begin statement. And then there's an exceptions, just like in programming language. So if exception handling statements, so if, say, a variable has some outstanding number, if it's greater than, say something is greater than 5,000, so like invoice is greater than 5,000, you may want to flag it for return. So you could say if invoice is greater than 5,000, then log the error or alert me to an error. So it's a way of like potentially logging errors or flagging some other issues instead of just getting a database issue. So you'll notice in class, sometimes you'll get a database warning or error that says invalid syntax or table does not exist. That's actually an exception that's programmed into SQL. So you can, with procedural SQL, you can create your own exceptions. So that's the structure of procedural SQL. So more about routines. So routines are a subset of procedural SQL, and they are stored procedures or functions defined and stored in a database. We saw that within, we can see those routines as objects within the MySQL database. So essentially, it's a broad block of SQL code that can be called and executed from within other SQL statements or programs. So we'll see like these are basically little programs that you can use the keyword call in MySQL, and you can run it from from other places. You can often run if you create a function, you could actually run that within your regular SQL code, and we'll see an example of that. You can call it within there and run it as part of your result set that you're returning. So especially stored procedures are commonly used to perform routine operations on a database. You may just script a bunch of things that you need to do in a database, like inserts, read, update, delete data. You can accept inputs through routines. So you can have a parameter list like this is. And then actually that's not a parameter list, but you can have parameters on the function. Kind of like think about like your date difference. You'll have a beginning date and end date. You can create procedures like that or routines like that. And then you could ask them to return an output. We'll see examples of that too. So it's an example of a stored procedure. You use the create procedure. You declare your variables, and then you do as to start and as begin to start your procedure in MySQL, and then you give it some instructions. So this is just a regular SQL. This is just a regular SQL, just a regular SQL expression, a regular SQL query, and then you end. So this one actually does have parameters. So how you would call it is that you use the exec statement and then update salary. And for the employee name, you're giving it John Smith. And then for numeric, you have 1,000. So if that increase your salary by 1,000. So one of the things that's big with stored procedures, this is often big in automation to run a stored procedure. Say you have some type of database task that takes multiple steps. Instead of having to run these individually each day, you can create a stored procedure and schedule it, and then just have it do the multiple steps. That's one of the biggest things with stored procedures is that it really automates insert, read, update, and delete data. I personally use functions a lot less, but I have used it before. I've created mathematical functions where it didn't really exist within the database, but I needed it to exist within the database. So I've done things like if you're doing a mathematical model, is to program it as a function into a database and then have it return the result. Or if you need some really specialized calculation within the database for whatever reason, and you need that operation to like populate another field, you're able to do that based off some values. You're able to do that. So functions are occasionally useful in my experience, but I use stored procedures frequently to automate different tasks, multi-step tasks. And we actually have an example of this. So in the updated examples PowerPoint SQL, I have provided examples. It starts on line 293, 299. It's class 9 advanced SQL. So we define, so there's a stored procedure here. I pull all of these from the Sequila database because I already had stored procedures and functions in there. And I just took this film in stock. I did send to SQL editor, create statement. And this is the logic behind the create procedure statement. So it has some advanced commands there that it declares. And then you begin with a query. And then you can do the rows that it returns and put it into a variable. And then even return that result as an out variable. So there's a lot here. These are basically these are the variables that you read in to the procedure. This one is your out variable, the one that returns the film count. So how you could run this is you can use this in regular code. So you can call film in stock, and you can do customer ID is equal to film ID is equal to 3, store ID is equal to 2, and return it in this variable. And then we actually use a regular SQL statement to say select that variable. So let's go ahead and run this. So this is what this procedure does, is that it tries to count how many films are, oh, sorry, you aren't able to see the screen. Oh, sorry about that. I just kept it on here. My apologies. Okay, so for everybody, I have the screen on there, so sorry about that. I'll just do a quick recap of what I've been talking about. So the objectives, talked about temporary tables and CTEs, syntax behind those, how you can use those and their purpose. I had a duplicate slide there. Talked about standard versus procedural SQL. Standard is what we've been using throughout class, through the first 7 classes. Procedural SQL is what we are learning about here today, which is like gives you your programming constructs like procedures, functions, and triggers. Where standard SQL, you run one query or statement. Procedural allows you to do multiple statements from top to bottom and have it like a programming like construct where it gives you more power than just a regular query. And then you could also, within procedural SQL, you can also use standard SQL. So the procedural SQL structure, I talked about this real quick. You have declare here at the top. So that's what optional, where you declare your variables or your different parameters for the procedure. It always starts with the beginning and end. You can write SQL or regular SQL within this begin statement. You can use any DML, DLL, and SQL built-in functions there to create your logic, and this can be multiple steps. And then you could create exceptions. So if there's an error, you can program it to give you a useful error message or log a useful error message. Okay. So SQL routines was just where we were at and the usage of stored procedures and functions, like using stored procedures for automating tasks. And this is really creating the procedure. Here you have these variables as you declare as parameters, and then you begin and you update employees, or you have your beginning end. You actually have your regular SQL here. You're doing update, query, and then how you can execute it is using the exec command with these two parameters. So employee name John Smith, and then increasing the amount by 1,000. All right, so got everyone caught up. Stored procedures and functions. We're just talking about stored procedures. They're good for performing common CRUD options. So this is a new term that we're bringing in. So this is read, update, and delete, or create, read, update, and delete operations. These are standard for like data storage. Data store or systems where you do data storage. So even within a relational database, you can create, you can read or query a table, update or delete. This is really good for automating those type of procedures, especially if it's a multi-step procedure. And what I was just explaining while we were on this slide is it's really good for automating tasks. Like instead of running a script every day, you can do the multi-step task, have a number of checkpoints in it, and then put it on a scheduler to do every day. That's huge as far as automation and not having to manually do things yourself. Functions, they return a single value, and in return, they return a single value given the function's parameter. So an example of this is calculating an aggregate value on a table column given the start and end date. So talked a little bit about this stored procedure. Let me get this to try to get this to full screen for presentation mode so we can see this a little bit better. Try to see this with this one's without bottom examples in small tabs or small text. And that might be about as good as we can get it here. That looks okay. Looks okay here in StreamYard. All right. So I'll try to zoom in on that picture a little bit if I can. Maybe I can't. But down here is where you can create a function, and then you give it a name, you give it parameters, start and end date, you declare what it returns, so it's going to return a decimal value. You give it a begin and end, you declare your variables, you even set a variable to the difference between the end date and start date that you enter. And then you have a query in here. So you have select sum of the sale amount into total sales from sales. So you're selecting it into this variable that you declared, where the sale date is between start date and end date. And then you could set the average sales as total sales divided by number of days. So you got the sum of the sales over all of those days, the number of days, which will return your average sales. So it's on the from the sales table is where this function specifically applies. And then you can put it in a select statement. So you call it just using its name and then parameters, just like you would some of MySQL's built-in functions like datediff or cast or others with parameters. So concatenating strings with multiple parameters and so forth. So this allows you the ability to create your own functions. And we'll bring up an example here. For anybody who missed it, the examples PowerPoint SQL has different examples now. For Class 9 Advanced SQL, there's a stored procedure. And then this is how you would execute a stored procedure, is that you use that keyword call, and then you use the name of the stored procedure. You give it parameters. So in this case, it would be film ID 3, store 2, and then it's going to return the number. It's an out variable, so it's going to return the number of films that are at that store location for that film ID. So I give it a variable to return to, and then I can use that in my select clause. So if I were to execute that, it would give me a film count of 4 because there are 4 of them at that location. Just kind of cool. You can script parameterize things. Stored procedures are especially useful also. Another use is if you need some type of parameterized filter that where your dates changed often. So it's like a whole bunch of queries in one. You can just change the dates on it, and then it can return your value fairly easily. I've seen this done for report creation. So somebody created a report, they put the logic in a stored procedure, and then when the end user runs the report, they'll have like little entry boxes at the top of the report. They'll say start date and end date. Then that just sends it to the stored procedure and then returns the result that the end user wants. So also useful stored procedures in creating parameterized dynamic reports. So you don't have to constantly like run different queries for it. It's kind of a custom feature that the end user can use by putting in their own dates and their own filters and returning the result. There's also an example of creating a function. This one gets a customer balance depending on when the rental depending on the rental date. I couldn't actually find one of these that returned a value other than 0. So you see you can call that function right within the select statement and then return that as a value. So imagine you could also use columns in this from a table. So what it will do, if you use columns in a table, it'll work like a scalar. This one will work like a scalar function. So it go value by value, and it'll return you a list of values for each record. So there's value in that, and then as we saw in a previous example, you can also create this as an aggregate function also that gets you the totals. So lots of power in these procedural functions, these routines. Really, like oftentimes for either automation, stored procedures, or you're starting to do some customized calculations that the database doesn't already have. All right. So we're getting near the end of this lecture. Just really wanted to introduce everybody to these today, as you may see them in databases. The last one is SQL triggers. Triggers are database objects that automatically execute in response to insert, update, or delete options. So an example of this is preventing customer orders to not exceed a customer's credit limit. So this is actually a really common one. I've worked in a business where you want to do a credit check before you approve a transaction. So what you can do is you can write a database trigger, and it can give you an error message that says credit limit exceeded, and you could send that back to a program, and that program will pop up and say transaction denied, like credit limit exceeded. So that's a valuable use of that, and then you can decide whether you want to insert that into the database or not. Commonly used, so one of the common uses is to log data changes. How often, if a data is doing a bunch of update statements, you can log those so you could potentially trace back the changes. Make updates to aggregated tables, or enforce data integrity constraints. So if there's a value you don't want to be in the table, you can say if it's not in this set of values, then say value error. You can give it your own error message. So that's also useful. That's probably where I've seen it the most, especially in data warehousing. People who build and engineer the data warehouses, they'll often log data changes. It enforces data integrity constraints. And then when they have those error messages, they'll go back and investigate them and then figure out what to do with them. So it's really part of the automation. They don't want to wake up at 4 o'clock every morning to run data. So you do all these things, automation and triggers, and give you the error messages. So at 7:30 or 8, you can log in and check to see if anything went wrong, and then fix it before business starts. So you don't have to stay up all night and worry about if things went right or wrong, or being able to more easily find those things. Okay, so that's really it for this class. I wanted to introduce everybody to easier ways to do queries, temporary tables, and common table expressions. Those are probably things that you could include in your queries that you write right away to help simplify them. No, I definitely do. If I'm really putting together a complicated, complex query and I'm struggling to get the result that I want, I just break it down into smaller steps using particularly temporary tables, but also common table expressions. Both can also be used within procedural SQL. So knowing the difference between what we learned and the additional programming features really gives you an additional level of power within a database. And you can use standard SQL within procedural SQL. We learned the structure, syntax, and variable declaration of procedural SQL techniques, how you write these, and how they're structured. There's a lot of advanced things that we didn't cover in there, like little keywords. I'll leave those up to everybody else as far as eventually when you get to that point, being able to go out and do the research on those. But at least being familiar with these structures and potentially being able to use and create them is to your advantage. Even as a data analyst, being able to create a stored procedure that a data engineer or database administrator can take and implement can really help them out. And then SQL routines or stored procedures, triggers, and functions. Okay. So this will be very lightly on the final. I think there's one question at the end. And I wanted to thank everyone here too. As like I said at the beginning, class is my first time back in 2 years. So thanks for being my students and having patience occasionally when things were at the beginning, when technology wasn't quite working, or being able to do this online, or there were small things to adjust in the code or the homework. So I appreciate all the feedback and appreciate all of you, and hopefully it hasn't been pulling teeth or anything, learning a new technical skill. Hopefully you've found it enjoyable, and I definitely hope this is something that you can all use in your careers and your jobs. If you do anything with data in an organization, likely you're going to have to get out of a database, and I think these skills will be helpful for you in being able to work with that type of structured data. I do my best to cover it in 8 classes from beginning front to back as much as I can, and even give some of my like experience over 17 years of doing business, just about coming up on 17 years of doing business intelligence. So it helps you think about some of those things that you might come across. So I provided my information. You can find me particularly by email or LinkedIn profile. Feel free to email me about questions or career advice. Just stay in touch. Try not to make it emotional or anything, I promise. But you're my students, so let me know how it goes, and particularly about career advice or anything else I can help you with. And perhaps if you take the data engineering path, we'll see each other in the cloud course. All right. So that's it for this class. Just wanted to thank everyone and wish you all the best. So I'll go ahead and stop stream. So I don't mean for that to be everyone to go away. That's just, oops. We'll take a break. I'll end the stream for today.